Hello, everyone. We are in the middle of starting to talk about how to approach analysis. We've talked about descriptive analysis. We've analyzed the wisdom of the crowd's Fermi dataset. And we're right before talking about EDA and exploratory data analysis. And I go back and forth every time I teach this course about where it's best to have this lecture on data visualization, because we had those previous lectures about what good visualizations are, but we didn't really delve into how to do it in Python. But then in the last few lectures, I've shown some visualizations. So I always debate whether to show this before talking about descriptive statistics, but I think it's helpful to have a basic understanding of what the descriptive statistics are and how to describe a data set before we delve into talking about the tools for data visualization in Python. So in this class, we are going to use Seaborn as our basis for generating plots. This is a package in Python that at its base generates some pretty good visualizations with some defaults. So it doesn't take too much to get started making good plots in Seaborn. We're going to continue to use pandas for our wrangling of data. But I'm also going to demonstrate how to use matplotlib for fine-tuning plots. So matplotlib is a Python library, a package that allows you to really fine-tune plots. It also is a way to generate plots, but it takes a lot more code to make a basic plot in matplotlib than it does in Seaborn. None of these tools is perfect. There's also an additional data visualization tool in Python that I'm waiting to see if it gains more popularity, called Altair. So if you're really curious about visualization in Python, I encourage you to check that out as well. So we're going to focus on how to plot quantitative and categorical information here and talk a little bit about customizing visualizations. Now, for more on this topic, feel free to check out the links I've included here, including the Python Data Science Handbook from Jake Vanderplas and the Berkeley Data 100 textbook. We talked about this in last week's set of videos, but a good data visualization can help you identify anomalies in your data, where you can see these overall patterns as well as things that are weird or bizarre. Better understand your own data, understand the relationships between your variables, understand the range of values something can take, and it's really an effective way to communicate your findings. Those who are really great at visualizing and communicating data visually wind up being very successful in their positions because they can convince others of their ideas with the support from these visualizations. Okay, so here we are importing our normal working with data libraries. I'm also importing Seaborn. We saw this previously, but Seaborn is typically imported as SNS. So anytime we refer to a Seaborn function, we'll refer to it first with SNS. I'm also importing matplotlib in the typical ways. So matplotlib pyplot as PLT. This is the typical way of importing matplotlib, but some people you'll sometimes see MPL. This last line is to improve the resolution when I display it. If this doesn't work on your machine to improve resolution, you can comment this out. So I will run the code in that cell to get us set up. And as I mentioned before, Seaborn is a really great place to get started when generating plots that don't look awful. To do this, the first data set we're going to use is data from the COGS 108 class survey from spring of 2019. So this data frame is stored in the data directory within this folder. So df for viz is going to be what we're reading in as df. If we take a look, this was a class that was very large. So I had more than 800 people. You can see 843 responses to this survey. This was across 2 sections, and this was the first time I taught this course. So the numbers would look similar this quarter, but of course, the responses would look similar for the questions I've asked, but the numbers are much lower this quarter. So if we want to take a look at the data we're going to be using here, that quarter I asked about gender. I asked about lecture attendance. I asked whether or not they have a job outside of school. I asked about their comfortability on a scale from 1 to 10 in statistics and programming. I also asked about their comfort in a given programming language. So you all answered some subset of these questions, but not all of them, especially the lecture attendance one, as that was less applicable this quarter. The wrangling that I've done prior to making this data set available to you is I removed identifying information. So if there are any responses that only applied to 1 or 2 people, or I think it was less than 5, I removed that from the data set as to not make it identifiable. I standardized gender and job. So some people would have had a capital M for male or just a single M or a lowercase because I made it a free response so that any gender could respond with their gender. I also separated out programming responses, so people would have the opportunity to be familiar with more than one language. So somebody could have checked that they were comfortable with MATLAB and Python. I've indicated here a different column for each, where a 0 means they are not comfortable and a 1 means they are. So these are the data we're going to be visualizing today, the different types of charts that you'll be most often making when you are visualizing your data. So to describe these data, remember Java through SQL, these were all binary. It was either a 0 or a 1. So this is reflected in the fact that the min is 0 and the max is 1. The mean, the average for any of these gives you the proportion of people who responded yes, right? Because if you took the average of all of the ones and added those all up, divided by the number of people in the data set, this would get you the proportion of responses. So you can see that 81% of the data set said they were comfortable in Java, whereas 49% last spring said they were comfortable in Python. So that's the way to interpret it when you have a 0 or a 1 value here. When we look at programming, we can see that the average for programming was a little higher than the average for statistics. So people tend to be a little more comfortable in programming on average than they are in statistics. But we do have a full range with the min being a 1 and the max being a 10. So people did respond all across the distribution. Okay, so we talked before about quantitative variables having histograms, density plots, and scatter plots being helpful visualizations. And histograms and density plots can be generated using Seaborn's dist plot function. Again, these are helpful for single quantitative variables. What I'm doing here is just increasing the size of the plots that are going to display. We can now create a density plot with a histogram using the dist plot function. The syntax for most Seaborn functions will be to specify the data frame as well as the series that you want from that data frame. For histograms and density plots, we'll often need to specify how many bins we want to display. So here we can see that there are 10 bins, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We see the shape of the histogram. We also see the density plot overlaid. That's where density and dist comes into play. So by default, dist plot will give you both a histogram and a density plot. The x-axis will be the possible values for the variable you're interested in looking at, and the density plot y-axis will show. One thing to note here is that the histogram, the fact the number of bins being displayed plays a large role in what the viewer takes away from the visualization. So for example, if I made this number smaller and only showed 5 bins, it changes what we see in the visualization. Sometimes there's an even larger effect than when you decrease from 5 to 10 in other data sets. So know just instinctively, if you see a histogram, that the number of bins does alter what you take away from the visualization. If you just want the histogram, you can still use dist plot, but you just set that you want the KDE, so the kernel density, to be false. And this generates the histogram, where now the y-axis is the count of the number of observations that fall into each bin. So we can see the distribution that most people were a 5 or above, but there was a large subset of the class who felt they were a 1 through 4 in statistics. One thing to note here is that this plot does not follow visualization best practices. We talked about these last week, that you need to not only choose the right type of visualization, but be mindful of colors, label your axes, make text big enough, keep it simple, follow the less is more principle, improve your data to ink ratio, and that everything on the page should serve a purpose, and if it doesn't, remove it. So we've seen this before. Let's keep this idea of less is more in our minds to improve that original plot. I had SNS set here as font scale 2.5 to increase the overall font size and set the style as to white. This will set it for all plots after I run this code. So once I generate this, I can then create the same plot, but making a few changes. I'm specifying that I want the color to be gray. Gray is a really great default color for visualization. Here I'm using a hex code for gray I like. Keeping the bins as 10, so I haven't changed anything there. But you can see now that I'm storing it in AX. This stores the axes, which then will later on allow me to add information on top of it. So this is where matplotlib comes on top of it. So once I've stored it in AX, I can set a title, I can change the Y label, I can change the X label. And in the middle, I'm despining, removing those top and right lines. So you're going to see that I'm going to remove lines from the chart. So what we see here now is we only have left and right, left and bottom axes, because those serve a purpose. If I were to put a box around everything, those lines would not serve a purpose. I've removed the background. I've made everything gray. I've added a title. So most COGS 108 students are moderately comfortable with statistics, right? It tells you what you're supposed to take away from the visualization, and now the text is larger. We can go through this with the other variables in our data set. So for example, here I'm showing a density plot for programming. Notice that I've set hist equals false, still using the distplot function, and specifying now that I want the series programming. Dspine, added helpful title, Y label, X-axis label, and you can see the shape overall, right? There's more people who tend to be comfortable with programming. Most people in the class are somewhere between a 6 and a 10. Scatter plots, unlike histograms and density plots, are helpful when you have two quantitative variables. Here, the Seaborn syntax, the API is a little different. You still call SNS, you call the function you want. Now we're using scatter plot. But here, because there are two variables input, it allows you to input an X and a Y. So here you're just specifying the column name as a string, and then you specify which data set it's coming from. Now, there are capabilities within Pandas to make most of these plots. I've included some code for alternatives here. On your programming assignments, on your final projects, you are free to use whatever you want to visualize. I'm using Seaborn throughout, as it's a good place to start, and it can make better visualizations with fewer lines of code, but you are free to use what you want and what you're comfortable with. So here we've generated a scatter plot where we have programming and on the x-axis and statistics on the y-axis, and I'm curious to see the relationship between them. So this is often where I pause in lecture and have people try and figure out what's going on. So feel free to pause and think about this, interpret it before I explain. So what we see here are people could only choose values 1, 2, 3 through 10. And so anytime you have a point, demonstrates that there was a person who said they were an 8 in programming and a 10 in statistics. So we see over here, there were people who said they were a 1 in programming and a 6 in statistics, but we didn't have anybody who said they were a 1 in programming and a 1 through 5 in statistics, right? So anywhere there isn't a point is there was not a person who fell into that category. What we can't tell from this visualization is how many people fall into each of these, because the dots are all overlaying one another. There are ways around this in visualization, and there's this concept of jittering, which just is going to spread out the values a little bit in the X direction and a little bit in the Y direction. When I do this, I'm going to generate a plot that shows the relationship between programming and statistics. We can now better see each individual plot. How many people fell into each was completely lost on this previous visualization. So it's really important when you're visualizing your data to understand what's going on and to be able to interpret it in a way that's meaningful. So here we can see there are more people over here than over here, but there isn't necessarily a huge trend, right? Everybody who says they're a 10 in programming isn't necessarily a 10 in statistics. It's kind of random across the board. So we have people with all levels of statistics and programming experience in this class. Now, when you want to plot two numerical variables, but want to get some insight about a third categorical variable, you can color the points on the plot by the categorical variable. So one example we have here is first defining the color palette. Python, depending upon which approaches you're taking to visualization, none of them have great defaults. None of them allow you the flexibility or the consistency that you would want with ease. So here, I want to make sure that anytime I refer to lecture attendance, it has the same colors. So I'm defining a palette ahead of time. I'm then going to pass that palette into the visualization I'm creating. So what we can see is that I'm updating the palette here and then creating the plot I want and specifying which palette to use. So it's a lot of code, harder than we would want it to be, but know that it is capable, you are capable of making these changes to your plots. It can take some time to figure out. It's not always the easiest or most intuitive, but know that you do have the ability to control your plots. So here I'm showing that same scatter plot with the jitter, but I've colored by gender. So I've grouped everybody who didn't answer female or male as other or prefer not to say to make these less identifiable. And what we see that there are green plot points and red points all over and some purple points throughout. Note that we don't get a ton of more information here. We may see a slight shift in programming comfortability to include more males relative to females, right? We see a higher density of red over here and a higher density of green over here. But to better understand this, it's always worth thinking, is this the best way to visualize this information? A box plot might be better, and we'll look at that in just a second. Now that we've talked about histograms and density plots and scatter plots and seen how to syntactically generate those using Seaborn, let's look at bar plots and group bar plots and stacked bar plots. So when you want to create a bar plot of a categorical information, like lecture attendance, count plot is the function you want from Seaborn. So here, again, you have your X equals and the column you want, and then data equals df syntax. That's the API for count plot. And you can see that by default, there is a count plot generated, and the variable name is put as the x-axis label. Again, this isn't a great visualization. Let's use some of those tactics to clean this up a little bit. And what I did was change this to either attend or not attend, make this fewer words, change this to be lecture attendance preference, add the count, and then include a title. So most COGS 108 students prefer to attend lecture. So this was the response. Now, it's always important to keep in mind who they are sending this to. They're sending it to me, their professor. So there's always maybe some bias in how people answer this. They might think that I care that they attend lecture more than I do. I'm really just curious to see what people's preferences are. Same idea for gender, a categorical category. So we have female, male, and other or prefer not to say. And we can see that there are more males than females in COGS 108. Same idea, using count plot, adding titles and x-axis labels, and making sure everything's large enough. One note is that it's often a good idea to order axes from largest to smallest in categorical data. So for example, what that would look like here is you would want the most prevalent off to the left and the least prevalent off to the right. This really helps our visual perception. Now, here's a warning. This is not from Seaborn. When you want to create a bar plot across different variables, different columns in your data set, it's just simply easiest to do this in Pandas. You can see that it's only 3 lines of code here to generate this. So here I'm showing the proportion of people in our class who have experience in one of these languages. So you can see that Java is, and this is true every quarter, the most common language that people are comfortable in, with Python being the second most comfortable. Grouped bar plots are the idea when we want to put different categorical variables together. So here, if we want to look at how lecture attendance preferences differ by gender, we can do that again using count plot, but specifying that we want to color it by gender using the hue parameter. Same idea here. We see that we have most COGS 108 students prefer to attend lecture. Here we have female, male, and other prefer not to say. Again, we're using the same color as we did previously, specifying that with the palette parameter, where we have females as green, males as red, and other or prefer not to say as purple. And we can see within attendance what our overall pattern is and within not attend. Because we have different numbers of males and females and other prefer not to say, comparing these counts is not all that helpful. You have to do a lot of visual gymnastics to make these comparisons. When you find yourself doing this, you need proportions, and this is where you want a stacked bar plot. So we're doing some data wrangling to make this happen. Again, this is not in Seaborn. When you're stacking bar plots, I just promise using Pandas is easier. So we're using the plot function from Pandas and applying that to our data frame that we generated up here, specifying we want a bar plot, that we want it to be stacked, that we want rotation to be 0 to make our labels not look ugly, and then adding a title. Customizing a bit at the end, and now we can see the proportion within each gender. And we can see that the proportion for females is a little higher for prefer to attend relative to males, and that's a little higher than for other or prefer not to say. Now we lose exactly how many counts there are by scaling to proportions, but we can compare more easily across gender. So these are all the things you should start to get comfortable with as you are generating visualizations. As for box plots and line plots, we saw what a box plot and how to interpret it in the descriptive statistics analysis. As a reminder, the bar in the middle is the median. This is the 25th percentile. This is the 75th percentile. And to determine the outliers, we can again calculate the lower and the upper here. 4, 7, 25th percentile, 75th percentile. Calculate the IQR, that is the difference between the two. And then the outlier is 1.5 times the IQR. So what we do to get the lower cutoff is the lower value, the 25th percentile, minus 1.7 times the IQR. Upper, same idea, but with an addition sign. The lower cutoff and the upper cutoff are negative 0.5 and 11.5. And so you can see that we have negative 0.5 and 11.5. Nothing is outside those, so we don't see any outliers displayed on the chart. So that's how we determine what an IQR is, what the outliers would be. Now, box plots really shine when you want to look at the range of typical values for a quantitative variable broken down by a separate categorical variable. So for example, if we wanted to look at a box plot with gender on the x-axis, how people answered their response to the comfortability with statistics on the y-axis, use the data frame, and then again, use that palette I defined earlier. We can do that, and we can see in a box plot quickly how it differs across categories. So really, the conclusion here is that gender is not related to comfort with statistics. Sure, we see a little shift in median, but the difference between the 25th and 75th percentile is pretty much none across the different groups. Swarm plots are a version of a box plot where you can get an idea of how many people fall within each category. And these can be very helpful to see exactly how many observations fall within a box plot. So we can see that there are fewer people in the other or prefer not to say category. Now, a note about histograms and categorical variables. That same data I just displayed can be visualized with 3 histograms. So I can put 3 histograms and 3 density plots on top of one another. But the conclusion here is largely that they overlap, and the nuances between them isn't very clear. It's very busy, and it doesn't do as good a job as the box plot does. Further, you can also generate box plots by more than one categorical variable, right? So we have gender here broken down by whether or not somebody has a job and their comfortability with statistics. I want to note that this is starting to get busy, and it's worth considering whether or not all of this information should be on a single figure if it's necessary, or if there's a way to improve it. Okay, a few notes before we finish up. This is a different data set here, but I wanted to demonstrate that things can get complicated, and sometimes it takes a whole bunch of code to make the visualization you want. So here's a data set about births. You can see that we have information about the year, the month, the day, the gender, and how many births there were. So for the same day, there would be a female and a male category in this data set. And here's some code to calculate and wrangle the data and make a visualization. And we can see the data in this data set plotted between 2012 and 2013. So this is just January through December for a given year. And we might wonder, what are all those dips? Well, let's annotate a bit to explain what's going on. So we're adding annotation to this plot. We can generate this figure, and we can see that people tend not to go to the hospital and have their child on a holiday if they can avoid it. Right, these annotations add a lot to this plot, and we can see this average summarized across years. I'm doing this here and not walking through the code very specifically to let you know what's possible, let you know it's worth working to annotate your plots if it's going to help the interpretation of your visualization. It will take time to figure out exactly how to get them on your plot where you want, but they really go a long way. So when you're doing your final projects in this class, it's worth spending the time making a very good visualization with annotations, with great titles, with good axis labels. Now, when you're just exploring your data set before you get final plots, it's fine to not spend that extra time. So whenever you're going to share a visualization and communicate to somebody else, it's worth spending the time adding the annotations, making sure everything's large enough, but know that it takes time. The last thing is you can save plots. So there is a function called save fig, and you can give a path to your figure and save that image out. So whatever you just saved in fig, the last figure you generated will be saved out to this path. You can save a whole bunch of different types of files, including PNGs and JPEGs, and you can read them in. So you would need to import image from IPython display, and then call image, give it the path to your figure, and you can then read a figure in. So know that all of this is possible. You can also read images in using Markdown rather than the image function. All right, that's it I have for now, giving a rundown on Seaborn. Don't forget to take the Canvas quiz.